Today we are going to do lesson 36, ratio and sample space. A ratio is basically a way to describe a relationship between two numbers. So there's several ways that we can write these out. So ratios can be written out with the word to, T-O. So we would say something like this, 3 to 4. If we're talking girls to boys, there's 3 girls to 4 boys in the class. You can write it as a fraction. You're still going to read it the same, but this is going to be written out as this, 3 to 4. As a decimal number, 0.75, because 3/4 is 0.75. Or you can write it with a colon. You're going to read it the same, 3 to 4. So let's do a couple of these. Example number 1. It says, in a class of 28 students, there are 12 boys. So the first question is, it wants us to say what the ratio of boys to girls is. So there's 28 students, and there's 12 boys. If there are 12 boys, we need to figure out first how many girls there are. So 28 minus 12 is 16. So we know that there are 12 boys and 16 girls. So what is the boy to girl ratio? So we know there's 12 to 16, which I can reduce down to 3 over 4. Or I could say 3 to 4. One of those is how you would say it. Or you could actually say 3 to 4. Not in a decimal. In this case, you are not going to use a decimal. So now it wants to know what the girl to boy ratio is. So in this, it's 16 girls to 12 boys, which we're going to reduce this down to 4 over 3. Now here's where I'm going to caution you. You never write these as a mixed number. Because it is a ratio, you're going to leave it as an improper fraction. Reduce it, but do not make it a mixed number. So 4 to 3, you could also say 4 to 3 or 4 to 3. You do need to lead with whatever it is leading with. So in the B's case, it was girl to boy, and in A's case, it was boy to girl. That's how you know which number to put where. All right, example number 2 says the team won 4/7 of its games, or 4 out of 7 of its games, and lost the rest. What was the win-loss ratio? So if they won 4 games out of 7, how many games did they lose? Well, there were 7 games total. So we're going to say 7 minus 4 equals 3. So their win-loss ratio, their wins were 4, and their losses were 3. So it was a 4 to 3. You could also say it 4 to 3 or 4 to 3. One of those ways. Example number 3. There are red marbles and green marbles in a bag. If the ratio of red marbles to green marbles is 4 to 5, what fraction of the total number of marbles is red? So we know that there are 4 red marbles. So our ratio is going to be 4 to something. We just need to add these together. So 4 plus 5 is 9. So we know that our total number of marbles is 9. So our ratio would be 4 to 9. Or we could say 4 to 9. Or we could say 4 to 9. That would be our ratio. So before we learned all about probability, and it's to help us count all of the outcomes that are possible. So to help us with this, we are going to use something called sample space. The list of all possible outcomes is basically what we call our sample space. So in example number 4, what is the sample space for the following experiments? So basically we want to know our sample space is all of the possible outcomes. So I want to know what all of my possible outcomes, or my sample space, if I flip a coin once. So if I flip a coin once, my sample space can be, we're going to use braces for this, heads or tails. Those are the two possibilities if I flip a coin. If I flip a coin, it can land on heads. If I flip a coin, it can land on tails. Those are my two outcomes, so therefore my sample space is heads and tails. I want to know if I roll a number cube once, what my possible outcomes are, so my sample space. If I roll, I could get a 1, I could get a 2, a 3, a 4, a 5, or a 6. So my sample space is 1, 2, 3, 4, 5, 6. I want to know what the sample space is if I pick a letter from the alphabet. So my sample space is equal to A, B, C. I can use these ... to signify what's in between of these, and then end with X, Y, Z, instead of writing all of those out. But basically, your letters from the alphabet, your sample space would be anything from A to Z. Okay, so when is this going to come in handy? Well, it's going to come in handy when I'm trying to find probability. So if, in example number 5, if I have a fair coin, basically a fair coin is something that has heads on one side, tails on the other. So a coin is flipped and a spinner is spun. So we've got a coin, we also have a spinner. What is the sample space for one coin toss and one spin? Okay, so if my probability for the coin is heads or tails, that would be my sample space for the coin itself. But my spinner, it's a spinner that has 4 possible spots, a 1, a 2, a 3, and a 4. So my outcome for heads, I could do heads and spin a 1. I could do heads and spin a 2. I could do heads and spin a 3. I could do heads and spin a 4. I could flip a tail and spin 1. Flip a tails and spin 2, flip tails and spin 3, flip tails and spin 4. So these are all of my possible outcomes. So my sample space for the coin flip and the spinner is going to look something like this. Heads 1, heads 2, heads 3, heads 4, tail 1, tail 2, tail 3, and then tail 4. That is my sample space. So now I'm going to use this information to find out what the probability of heads and a number greater than 2. So if I want heads and greater than 2, that is my probability that I'm looking for. Well, if I'm looking at my sample space up here, this is heads greater than 2, this is heads greater than 2. So I have 2 possible outcomes that would satisfy my desire of heads first and then greater than 2. But then I need to count how many possible numbers there are. There's 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes in my sample space. So 2 out of 8 is my probability of spinning greater than 2 and flipping the coin and landing on heads. I need to reduce this down though because I cannot leave it as 2 over 8. My actual probability is 1 over 4.